All right, the second of these three videos is going to take a look at reflections going over the X and Y axis, and then we'll also talk about what a reflection through the origin looks like as well. So we talked about transformations in the first video, and we focused mostly on translations. We were shifting the graphs up, down, left to right. Now we're going to reflect them over a given line. We're going to be talking about reflections over the x-axis and the y-axis, and then we'll talk about a combined reflection as well, going through both of them. So let's just talk about reflections first of all. When you take a point of coordinate here of x, y, and you reflect that over the x-axis. So here's my x-axis. When I reflect it over the x-axis, it's a mirror image of itself. So that means that your x value is going to stay the same. It's your y value that's going to become the opposite. A lot of people get that mixed up. They think, okay, x-axis, oh, it's the x value that's going to switch, when actually it's the y value that's going to become the opposite, because the x values are directly over each other. We're just going from being above the x-axis to below the x-axis, and that right there is going to change the y value. So when you're working with a reflection across the x-axis, notice that there is a change in your y value. One becomes positive and the other one becomes negative. When you do a reflection over the y-axis, so here's our y-axis. If I do a reflection in a mirror image over there, it's going to be the same distance from the y-axis that's here. Notice this time that your y value stays the same and your x value changes, because you're going to be the same distance above your x-axis. It's just whether you're on the left or the right of it. So one's going to be positive and one's going to be negative. We also have something which is called a reflection through the origin. And it's talking about the distance from 0, 0 and reflecting that through the origin. It's going to take you really to the opposite quadrant. Well, what ends up happening here is that when you do a reflection through the origin, you're doing two things. You are doing a reflection over your x-axis, and you are doing a reflection over the y-axis. And so, for example, if I reflect over my y-axis first, so I'm starting here, reflected over my y-axis, which puts me right here, and now I reflect that over my x-axis, which puts me down here. If I take the coordinate negative x comma y and I reflect that over my x-axis, the x will stay the same, the y is going to become negative, so I get negative x, negative y. What ends up happening with a reflection through the origin is that both of your x values become the opposite sign. So I went from x, y in quadrant 1 to now negative x, negative y over in quadrant 3. A reflection through the origin is when both are taking place. So now what we're going to do is we're going to talk about, well, how do you work with these reflections with our parent functions? So let me just go ahead and start with our linear function. So f of x is equal to x. All right, so now if I reflect this over our, we'll start with x-axis. If I reflect this over the x-axis, everything that's up here in the first quadrant is going to be flipped down here, and it's going to be down here in the fourth quadrant. Everything that's in the third quadrant would end up here in the second quadrant. There, my parent function would be a flip over the x-axis. Well, now think about what's different about these, and even what's the same. They both still intersect at the origin. We still have a y-intercept of 0. But what's changing now is the slope. Here I have a slope of positive 1, and here I have a slope of negative 1. When thinking about that then, if I'm looking at this function being, we'll say, h of x then is going to have a different slope. It's going to be negative 1x. It'll still be plus 0, so h of x is going to equal negative x, when f of x was equal to positive x. Now that's a reflection over the x-axis. Well, if you were to reflect this also, let's say, over the y-axis, let's say you took your parent function and did it that way. So now we're going to reflect our parent function over the y-axis, which is right here, everything that's in quadrant 1 would now show up in quadrant 2, and everything in quadrant 3 would be in quadrant 4. Well, this graph right here is the exact same thing that we just talked about in the last problem. So, with a linear function, a reflection over the x-axis and the y-axis is going to result in the same graph. And that is because it is an odd function. It has rotation symmetry that we talked about earlier in the chapter, and that right there is a reflection through the origin. Let's take a function like the quadratic instead. All right, so if I were to take the quadratic right here, and if I were to reflect that over our x-axis, so we've got y equals x squared here, reflect that over, that is what gives us our upside down parabolas. Now, if f of x equals x squared, and we'll say that g of x, how we would get a parabola that opens down? Perhaps you recall that in order to have a parabola opening down, you have to have a constant term out in front of that x squared of being negative. So a negative x squared would open it down for us. Now notice that with our quadratic here is that it has y-axis symmetry. If I were to reflect it across the y-axis, I would get the exact same function. Okay. So reflecting it over there, we'll say that that's h of x. I would end up with x squared because it's the same thing. Well, now let's get into the rules that go along with the reflections. If you are going to reflect something over the x-axis, we are going to be taking the negative of f of x. Okay. Think about it here when we talked about our odd and even functions. Even functions, when they had y-axis symmetry, we said that f of x equals f of negative x. Odd functions, we were talking about how f of negative x equals negative f of x. Here's where that's coming into play. But if you're going to reflect something over the x-axis, we're going to be taking negative f of x. If we reflect something over the y-axis, we're going to take f of negative x. If I reflect something through the origin, I'm going to take both of them. I'm going to be reflecting it over the x-axis as well as over the y-axis. So let's take a look at an example. Actually, I'm going to go here first. Okay, let's say that we want to take the parent function f of x is equal to, let's take the absolute value of x. If I want to reflect that over the x-axis, so x-axis, I'm going to take negative f of x. So I'm going to take negative f of x. Well, what that means, I'm going to give myself a little bit more space here, negative f of x. So I'm going to take a negative of the function of the absolute value of x. So my reflected function, we'll just say that that's h of x, would be negative absolute value of x. Just like with our quadratic, you know, that negative out in front, which would open it down, here it's going to open our absolute value down. All right, let's take a different function. Let's take the function of square root of x. Well, if I'm going to reflect it over the y-axis, we're going to take f of negative x. And so in this case here, we'd be working inside the function. So I'd be taking the square root of negative x. And we would end up with h of x is equal to the square root of negative x. Let's try looking at something going through the origin. Let's take f of x is equal to, I'm going to go the natural log of x. So here I'd be taking the negative of f of negative x. So in doing that, I'd be taking the negative of the natural log of negative x. So now h of x would give me negative natural log of negative x. All right, let's take a look at a couple. Let's take the function h of x is equal to, actually, oh yeah, okay, sorry. H of x is equal to, just trying to think of how I want to make this roll. We'll go negative x squared, okay? So when I look at this here, hopefully what's jumping out to you is the fact that, you know, this is dealing with our parent function of the quadratic of x squared. Because this negative is outside of the function, okay, that is a reflection over the x-axis. So I would be reflecting my graph over the x-axis. It would be down here. If I saw that inside the function, and I had the parentheses negative x being squared, that would be a reflection over the y-axis. Now here, a negative number squared is always positive. So really here, this is the exact same thing as x squared. Therefore, the parent function as well as the reflected function are the exact same thing. All right, let's take the reciprocal function. So let's take f of x is equal to 1 over x. If I were to take this function and I wanted to, let's do a reflection, let's do a reflection over the y-axis. Okay, so I'm going to reflect it over the y-axis. So that would be f of negative x. So if I want to evaluate f of negative x, I'd get 1 over negative x, which is the same thing as negative 1 over x. That would be my function. So my new h of x would be negative 1 over x. If I take its parent function, which is right here, reflect that over your, I said y-axis, right? Yes. Reflect it. Everything here that's on the right-hand side is going to go over to the left. So I'd put that branch here. Everything in the left would go to the right. And so those two green lines there would represent the new function. Let's do let's reflect one through the origin. So let's do, I'll do an exponential one. We haven't done one like that yet. F of x is equal to e to the power of x. So here's our exponential growth problem. And we're going to reflect this one through the origin. So if we're going to reflect through the origin, we have to take negative f of negative x. We have to do both. So negative of the function f of negative x would be e to the power of negative x. And so this would end up giving me h of x is equal to the negative e to the power of negative x. Reflecting both, if I took this graph right here and I reflected over the y-axis, that would give me a graph that looks like this. Now I'd have to reflect that over the x-axis. And so the blue graph right here would be our final one. That would be negative e to the power of negative x. All right, so let's combine some reflections with translations now. For example, I'm going to work with a quadratic. So we're going to take, let's go f of x is equal to negative of x plus 2 squared. We'll just start here. All right, so what's happening here is you have a quadratic that two things are happening. You've got a translation, which we're going to be shifting it, as well as a reflection. This x plus 2 right here Okay, that's dealing with the inside change, and this right here is dealing with the outside change. The inside change there of x plus 2 tells us that I'm shifting my graph over here to the left 2 units. So right here, this is telling us that we're going to the left 2 units. This negative over here is telling me that we're going to reflect this over the x-axis. So shifting it over 2 units and flipping it over the x-axis is going to end up making our graph open down and be over to the left. So that changes it up a little bit. Okay, let's try another one. Let's go with, I'm going to pause this before I think of one. All right, so I came up with this one to do, let's go log of x. We did a natural log base 10, same looking thing. So log of negative x plus 4. So we have inside change and outside change that's happening. The outside change here is telling us that we're going to be moving this up 4 units. The inside here, the fact that it's negative x, is going to tell us that we are going to be reflecting this over the y-axis. So if I move it up 4 units, I should have actually had this point going through better. Okay. So then I'd want to move this up 4 units, 1, 2, 3, 4. So if I think about what that graph would be like going up 4 units, and then I'm reflected over the y-axis, and so I would end up with a graph that looks like this. Okay. All right, the trickiest part is if you're working with something that has both a translation as well as a reflection over the y-axis, because you're working with that inside change. Okay, so we're going to take a look at just kind of the algebraic side of things. Earlier, we said that f of negative x is going to be a reflection over the x-axis, and negative f of x is a reflection over the y-axis. Alright, so now let's say that you have a function. I'm going to work with a quadratic here just because sometimes it's a little bit easier to visualize those. So let's say that you have g of x, which is a function that you have the quantity of x plus 2 squared plus 3. All right, so this right here, if I were to say that that's my parent function, that's the function I'm starting with. The plus 2 right here would be telling me that this parabola has been shifted over to the left 2 units. And the plus 3 right here would say that it's being up 3 units. So I'm going to graph that out first. So I'm going to go, all right, so I'm going over to the left 2. I'm going up 3, 1, 2, 3. Here's my point. Here's my parabola that I'm looking at. If I wanted to reflect this over the x-axis, so I would be taking g of negative x. What's going to happen here is inside my function is going to become negative x plus 2 squared plus 3. Well, there's really not much that's happening here. With this being a reflection over the x-axis now, or did I, f of negative x, sorry, I switched these around. Sorry, this should be y-axis up here. I apologize. And this should be x-axis. My fault. So when I look at this here, that negative x inside of there is telling me that I'm going to reflect this over the y-axis. So where my y-axis is, here's my y-axis. That point now of negative 2, positive 3, now it's going to become positive 2, positive 3, and there's my reflection over the y-axis. Now, if you're working with something over, let me get rid that. Let's do negative h of x. So we're going to do, well, I'll just do negative g of x. So now we're going to reflect it over the x-axis. This is going to be the negative of this entire function. So it's going to be negative of x plus 2 squared plus 3. What this is going to do now is it's going to change two things. It's going to make this a negative x plus 2 squared. It doesn't do anything to the plus 2 in there, but it's going to make this a negative 3. So now if I take this graph right here, which was 3 units up, now I reflect it over the x-axis, which is now the vertex is going to be at positive 2, negative 3. What's happening here is the graph that goes along with it is going to resemble that. Notice here that the x plus 2 inside here still indicates that we're going to shift it to the left 2 units. The negative 3 that's on the outside of this is going to indicate that we're going to be shifting it down 3 units. The negative that's out in front of your quantity here is going to indicate that it's going to be flipped upside down. So just be careful about your outside part of the change. When you do more than one reflection, it makes it a little bit more of a challenge. All right, so let's see where I stop there.